All right, let's go to page 19. So we're going to talk about investment. So when you put money in a bank or you put money in a stock, you can grow your money. Or when you, I don't know, when you buy something and that thing is valuable, like I know a lot of the guys, they like to buy shoes. And sometimes when they sell it later, they get a higher price. So you kind of look at the return on that investment, right? So what interest do you get, or what, how much do people actually pay from that? Okay, so usually there are three types of interest. One is called the simple interest. Just what do you get back? Only one interest amount that's going to come back. Usually this is what they test you on SAT because it's just the easy one. Next one is called the compound interest. Compound means that when you get the interest back, it goes back into the original amount, and then you get more interest on top of your interest. So that's the nice one. Does that make sense? Mm-hmm. So like you put $100 in, 5% interest back, that's $105, right? You put that 105 into the 5% again, you get 5% on that, and then that keeps rolling more and more interest. Make sense? That's called compound. That's the nice one, which is the one you want to invest if you invest. The last one is also called compound, but it's a little different. The second kind has an interval, so like every year 5%. So then if you put it in there for 10 years, then you get interest 10 times. The other one is continuous, meaning that every second of the day it is increasing all your money. So every second of the day it's rolling like crazy. Okay, that would be really nice, but nobody is going to do that. That's too much money to give back to you. All right, so let's give you the equations for all three. Simple interest. This is like the interest that you don't want to use, you don't want to get because it's too little. A means the amount you get back. P means the principal, meaning the amount you put in, times. Well, you always get your money back unless it's a stock, right? Sometimes there's risk. But let's say that it is always going to get money back, then you always get 100% back, right? So that's 1. And then plus whatever interest rate they give you. But they only give you the interest once. That's why it's called simple interest. Does that make sense? So like you invest for 5 years, they said, okay, I'm going to give you 10%, but only once at the end of the 5 years. Yeah, it's terrible. Okay, compound interest at an interval. So A, again, is equal to your principal times. You always get your money back, so that's 100%, plus. This time, because you have a return over a certain amount of time every few some intervals, so your rate is not just the rate. It's going to divide by how many times this happen a year. Okay, so K is the times it happened a year. Okay, this is raised to the KT. Okay, I'll tell you what that means. For example, if this place you invest your money in says, I'm going to give you back money every month. How many times did you get interest in 1 year? 12 times, right? Okay, so if you choose another bank and they said, I'm going to roll the interest every week, then how many times a year do you get interest back? 52. We're going to say 52. 52 weeks in a year. Does that make sense? Okay, and if they say quarterly, I'm going to give you interest back quarterly, how many times a year? 4. Quarterly just means divide the year into 4. Okay, and then we'll look at that equation. And this actually simplifies to a different equation if you just have yearly interest. So every year it does an interest, then this simplifies to, let me double check, 1 plus R, and then to, let's just call it T so it's more consistent. So this is just the yearly, and this is like number of times per year. Okay, let me give you all the variables so it's not too confusing. Yeah?
Is the KT involved to the formula?
Yes, and I'll show you what that means. Okay, A is the amount you get back. P is the principal. Principal means the amount you put in. Okay, always it's kind of what it means. Okay, R is the interest rate. K is number of times per year. T is the number of years. All right, the last one. This almost never happens, but it does happen for other things. That doesn't happen to money. You're not gonna find a place that gives you continuous interest. If you have a continuous interest on something, it is A equals principal. But because we keep continuing to roll this interest every second of the day, it becomes E. And then to the RT. So this is the PERT equation, P-E-R-T, PERT equation. Okay, so let's look at some questions, and you're gonna tell me how things work. Okay, what's E? E is just the number we've been using, like all this E, 2.7 something. Okay, so if Kwang Lee invests $500 at 7% interest compounded annually, find the value of her investment 10 years later. 7% is not bad, but she put too little money in. Okay, we can find out. So if you only put 7% right now, 10 years later, how much are you going to get back? All right, first of all, let's think about which formula we're going to use. So I'm going to number this. 1, 2, 3. Okay, if she's going to invest $500 in 7% interest compounded annually, find the value of her investment 10 years later. Okay, hold on your fingers. 1, 2, 3. Which equation are you going to use? Everybody must vote. Everybody must vote. Only one answer. No. Only one answer. Okay, this whole area, only one person is voting. You guys guess. Which formula are you going to use? That's not it. That's not in one of the choices. 1, 2, or 3. Which one? 4. No. Okay. All right. 2 people are voting. You guys have to vote. You guys, Philip and Raymond and Murphy. Guess. Just hold up one number. All right. 2. The answer is 2. Why? Because there's an interval. Compounded, yeah, of course, the keyword is kind of compounded annually. All right. Okay, so we can use either the first one or the second one from the compounded one. It doesn't really matter. It will turn out the same. Okay, A equals, let's say we use the first one. P times 1 plus R over K to the KT.
Can't we just use the second one?
We can, but I just want to show you that it's the same. Okay, A equals. P is what? Principal is how much you put in.
500.
Good. 1 plus rate. How much is the interest? 7% and change that to 0.07. Okay, K is the number of times per year this interest rose. Bless you. Huh? How many times? A year. One time a year.
So can we just don't write one?
Yeah, exactly. That's why we can just use the second equation.
Oh.
Yeah, because it's just 1. Okay, and then K is 1 again. T is the number of years, so number of times. 10 years. Okay, so go ahead and calculate how much she's going to get back 10 years later. Please be careful. Remember pandas, you gotta do parentheses first, exponent, and then multiply.
Is it different?
No, it's the same.
I mean, the two equations. I use this one.
Yeah, it's the same.
It's same.
Because it's the k is 1, so then it really doesn't matter.
So am I right?
Yeah. But it's real world problem with money, so we should always end at cents. Mm-hmm.
So is the total money gone or just?
Great question. So at the end of 10 years, she has 983.58. What does this mean? Oh yeah, it's dollars, but it's how much she got back at the very end, right? That means that money has the original amount, the original 500 in there.
Right.
It's not $900 on top of 500. No, it's not just the interest. It's just how much she's gonna get back with that money she invested in the beginning. So she got like what 483 in 10 years. She just need to put more money in. So, kind of think about it like, I don't know if you guys know inflation. You know inflation? No, inflation is like, today $1 you can buy like, what can you buy with $1?
You can't even buy a candy.
You can buy iTunes song, right? $129. 10 years later, okay, let's say iTunes is still a good thing to do, and then 10 years later they still do iTunes, they didn't come up with something else. It usually will cost more, right?
Yeah.
Because the way things run, it usually costs more to buy things. So you can kind of say like, In-N-Out costs $3 and something like 5 years ago. Now it costs $4 something.
Yeah.
So that's inflation, right? So then your investment should outrun your inflation, or else you're just losing money. Does that make sense? Because if you can't run as fast as the inflation, you're just choosing a very bad investment. You're losing money 10 years. Right? Okay. Anyways, come back. All right. Suppose Roberto invests $500 at 9% interest rate. That is very nice. If you find 9% interest rate, you should invest. Compounded monthly, even better. Every month they give you 9%. Yeah, that's if you find that, please put as much money in as possible. Find the value of his investment 5 years later. That is quite a lot of money. Okay, compounded monthly, that means every year, how many times does this interest roll? 12 times. Okay, so yeah, 9%. So basically, if you can find something that gives you 10% consistently, you should put as much money in as possible, and then you can leave it there until retirement. Oh, you don't even want to think about it. You guys are too young to think about retirement. That is like 50 years later. Okay.
Some people do early retirement.
If you have enough money, yes,
Yeah.
a lot of people retire early. Okay, R over K to the KT. Okay, what's principal again? 500. 1 plus. What is the interest rate in decimal? 0.09. Okay, how many times a year? 12. Okay, and then K is 12. How many years? 5. That means in 5 years, it's going to roll 60 times. Does that make sense? Yeah. Okay, so go ahead and figure out the answer. All right, the answer is 782.84. Okay, let's go backwards. Judy has $500 to invest in a 9% annual interest compounded monthly. So she is investing the same thing Roberto is. How long would it take for her investment to grow to $3,000? $3,000 is now what? What variable? A. So again, we're going to use the same formula because it's pretty much the same problem. Okay, so 3,000 is A. So the question is, well, how long is this going to happen? Well, she still has $500 principal. She still has 9% interest, and this is still monthly, so K is 12. And that's 12 times T in the exponent. The question is, how do we get T? What do we have to do? Divide by 500. So this is 6 equals 1 plus 0.09 over 12 to the 12t. Oops, 12t. Okay, what's next? Log, yeah. Log both sides. Yes. 2? What's that? Oh. Okay, log both sides. I'm going to take natural log. So natural log 6 is equal to, bring down that 12t, and then natural log this whole thing. So you might want to just put that whole thing in natural log and get a number instead. Yes, go ahead.
Never mind. There's
Okay.
only 3 minutes left.
Okay.
Wait.
Yes. Yes, I am waiting.
Never mind.
Okay, all right. Okay, so go ahead and figure out what T is.
Whole number?
Let's do whole number.
Yeah, I was like.
Let's do whole number.
19.9.
Is it 19.9? I don't know.
98.3.
All right, so use your calculator, calculate the whole thing. Wenbo's deciding whether he's going to calculate based on I'm going to get an answer or not. Okay, it's about 19.98, so probably about 20 years. Oh, 20 years to get $3,000. That's so sad. So a lot of times when you do, problems in our class, you kind of have to ask yourself, does this make any sense at all? Like when you do an algebra problem and then your answer was like 50 watermelon in a car. You're like, 50 watermelon in a car.
I got 21.
21? Oh, you probably round it as you go. So yeah, just try not to round as much. All right, next. Steven has $500 to invest. They all should invest more.
We don't have time.
We do. What annual interest rate, compounded quarterly, that is 4 times per year, is required to double his money in 10 years? Okay, again, this is A equals P times 1 plus R over K to the KT. Okay, he has $500. He wants to double. So how much does he want to get back?
1,000.
1,000.
10 years? Why do you?
Why do you want to do that?
Yeah.
Okay, rate, we don't know. Quarterly, and then 10 years. So we got to go back and figure out R. Wimbo, take your iPad out. It's all packed and dressed up. All right. Now this will be a mystery. How long? What interest rate? Okay.